Hello, in this video lesson, we will answer some questions involving limits of the form of non-zero over zero. So we have few examples. First example is limit of as x is approaching 2 from the left of negative x over x minus 2. So first thing you want to do is plug in 2 for x. Since this x is approaching 2, first thing you want to do is plug 2 for x, see what's happening. So negative 2 and change x to 2, so you get 2 minus 2. So this is a negative 2 over 0. So this is a situation where we have a non-zero, which is negative 2, divided by a 0. Okay, um, this kind of limit require different strategies. So first thing, when you have a non-zero over 0, what you want to do, see if you can factor the denominator. Can we factor x minus 2? No, we cannot factor it. So we're going to do a number line like this. Since we cannot factor x minus 2, that's prime, we found x minus 2 to be 0 at when x equal 2. So we're going to plug the 2 here, investigating the limit when x is approaching 2. That 2 is the only number that causes the denominator to be 0. So what we want to do here is we're going to pick a number immediately to the left of 2. Will be easy to pick 1. And another number immediately to the right. Actually, we don't need to pick a number from the right because we're investigating the limit as x is approaching 2 from the left. So we only care about the left of 2. So we're going to pick a number, again, a number that's immediately to left of 2 because we're approaching 2 from the left. That will be 1. And we're going to plug that number 1, we're going to plug it in the denominator only. The denominator only. So we're going to change x to 1. So 1 minus 2. Because the numerator is already, we already know it's negative. It's equal negative 2. We're going to keep that negative 2 here. So again, we don't plug the 1 in the numerator. The numerator, we know it's equal to negative 2. But we plug 1 only in the denominator and see what kind of sign we're going to get. So we get a 2, negative 2 over negative 1, which is a positive answer. So we get a positive answer. So if we get a positive answer, the answer for this problem will be positive infinity. As a matter of fact, when you have a non-zero over zero, the only possible answer you're going to have is either positive infinity, negative infinity, or does not exist. In this particular example, we're going to rule out does not exist because every time we are doing a one-sided limit, this is called a one-sided limit. We're approaching 2 from the left. So that does not exist, will not be an option. So it's either going to be positive infinity and negative infinity. To determine which one is the correct one, we pick this test value of 1, we plug this in the denominator, or find the answer to be positive, so we know the answer is positive infinity. Next example, limit as x is approaching of negative 3 from the left of this rational expression. So first thing we want to do is change x to negative 3. Everywhere we have x, we're going to change it to negative 3. So negative 3 minus 1. The denominator, we get negative 3 squared plus 6 times negative 3 plus 9. If we simplify this, the numerator is going to be negative 4. If we simplify the denominator, we're going to get 9 plus 9 minus 18. So the denominator, if we simplify this, you're going to get 0. So another situation of a non-zero over 0. So what do we want to do? Again, we want to see if we can factor this. If you're always going to see if you can factor the denominator. In this case, we can. X plus 3, x plus 3. So once you factor it, you set it equal to 0 and solve it. So which numbers for x causes the denominator to be 0? It's only negative 3, because when x plus 3 equals 0, we found x equal negative 3. And of course, the other factor will also give you a negative 3. So the negative 3 is the only solution of this equation. So we're going to do a number line, and we're going to put the number for which we are investigating the limit, which is negative 3. And the solution is negative 3, so we don't have to write it twice. So the only number that causes the denominator to be 0 is negative 3. What we're going to do here, since we're finding the limit for when x is approaching negative 3 from negative 3, this is a two-sided limit. which means we have to consider the limit as x is approaching -3 from the left and from the right. So from the left, we're going to pick for test value a number immediately to the left of -3. That will be -4. And immediately to the right of -3, you can pick any number immediately to the right. That would be a -2. Okay. So these numbers, we're going to plug them separately into the denominator of my rational expression. So let's investigate what happened when we plug in, when we do a limit when x is approaching -3 from the left, meaning we have to plug in -4 as a test value in the denominator. Remember that the numerator is already decided to be a -4, so we don't have to plug in -3 in the numerator, because the numerator we found it to be -4. We only have to plug it in the denominator because it gives us 0. When we plug in -3 is 0, so we want to know if this expression is approaching 0 with a positive answers or negative answers. So if we plug in -4 for x, what do we get? -4 squared plus 6 times -4 plus 9. We simplify this, you get -4. That's 16 plus 9, 25. Looks like a 25 minus 24. So that's a positive, that's a negative answer. -4 divided by 1, that's going to be a negative answer. We get a negative answer. That means when x is approaching -3, limit when x is approaching -3 from the left, we found an answer to be a -infinity. Okay, now we're going to do, what we're going to do, we're going to investigate the limit from the right. As we're approaching -3 from the right, we're going to plug in -2 for x in the denominator. Again, the numerator is decided to be -4, but we're changing x in the denominator to -2 squared plus 6 times -2 plus 9. If we simplify this, we get -4. That's a 4. 6 times -2 minus 12 plus 9. So that's a -4. That's 4 plus 9, 13 minus 12 is 1. So it looks like we get a negative again. We get a negative. So, which means that limit as x is approaching -3 from the right, it's also -infinity. Okay, since these two-sided limits, each one of them is -infinity, they match -infinity and -infinity, then the answer to my original problem, the two-sided limit, is also going to be a -infinity is the answer. Something worth mentioning here is we didn't have to do all this work. If a student realized that the denominator is x plus 3 times x plus 3, it's basically x plus 3 squared. What is x plus 3 times x plus 3 when we factor? That's really x plus 3 squared. So something squared, the denominator will always be positive because you have an expression that's being squared. So the denominator, it doesn't matter what you plug in for x, is always going to be positive. Of course, you cannot plug in -3 because it gives you 0, but any other value will give you a positive answer. So the denominator was always positive, and the numerator, we said, we found it to be -4. So -4 divided by positive is always going to be negative. So we didn't have to do all this work if you realize that that's x squared plus 6x plus 9 is a perfect square. And you know that definitely the answer will be -infinity. Okay. Another example here is limit when x is approaching 2 from the right of this rational expression. Again, you plug in 2 for x, you get, don't forget this negative here, so you get -4. 2 squared is 4. You can use this negative here, apply it to the numerator, so it's x squared, 2 squared is 4, but you still have a negative, so we make it -4. Now we plug in 2 for x on the denominator, you get 2 times 2 minus 4. Again, that's another situation where you have a non-zero, -4 divided by 0. Even if you factor this, again, I want to be consistent. Can I factor 2x minus 4? Yes, you can factor it as 2x minus 2. And if you set it equal to 0, the only solution you're going to get here is x equal to. So the only number we can put on number line is 2, which is the number at which we're trying to find the limit, 2, right? So what are we going to do now? We're going to pick a number immediately to there. Actually, we don't have to do the left because this is x is approaching 2 from the right. So this is a one-sided limit. This is a one-sided limit. So we only have to investigate the limit as x is approaching 2 from the right. So from the right, this way. So we only have to pick a number immediately to the right of 2, which is a 3. Okay, that 3, we're going to plug it only the denominator of that expression. Remember, the numerator is decided to be -4. You plug the 3 in the denominators, change x to 3. So 2 times the 3 minus 4, that's -4/6, which is going to be a negative answer. You're going to get a negative answer. -4/2, just a negative answer. So we know for sure that, and the answer will be -infinity. This answer is -infinity. Because what did I mention earlier? That if you have a non-zero over 0, the only possible answer you have is -infinity. Positive infinity does not exist. We're going to rule out does not exist in this problem because that's a one-sided limit. One-sided limit, the answer will never be does not exist. So we only have to find out if it's -infinity or positive infinity. So since when we tested, we found a negative answer, so it's -infinity. Question 4, same thing. You plug, change x to -1. Again, this is a one-sided limit. We're approaching -1 from the left. So -1 squared, change x to -1 minus 1. The numerator is just 2. So this gives us what? 2/0. So again, a non-zero over 0. What are possible answers? -infinity, positive infinity does not exist. We're going to rule out does not exist, again, because it's a one-sided limit. So the answer either going to be -infinity or positive infinity. Okay, before we do anything here, can we factor this? X squared minus 1. Before we do the number line, see if you can factor. That's x minus 1 times x plus 1. Set it equal to 0. What are the possible answers? X equal 1 or x equal -1. Those are the two values that make this expression equal to 0. I would like to put these two numbers on a number line, -1 and 1. While investigating the limit, I put 2 zeros here to indicate that this expression, the denominator is 0 at -1 and 1, where we care about the limit when x is approaching -1 from the left. So -1 from the left is this way, approaching -1 from the left. So what test value we can pick? Something immediately to the left of -1, smaller than -1, that will be a -2. So this is my test value. We're going to plug that in the denominator only. Okay, the denominator only. Remember, the numerator is decided to be 2. So 2 over, change x to -2. So -2 squared minus 1. That's 2 over what? -2 squared, that's 4 minus 1, 2 over 3. That's a positive answer. The answer is not 2 over 3. Just plug in to see if the answer is positive. So since it's positive, the answer will be positive infinity. This answer for this problem is positive infinity. Okay, last but not least, question number 5. We're going to plug in -3 for x. Everywhere you see x, you change it to -3. Don't forget about this negative in front. We're going to apply it to 4. So it's a -4. X is -3 multiplied by -3. Denominator is just change x to -3. That's -3 plus 3. So we get 12 over 0. So again, what are the possible answers? This is a non-zero over 0. Possible answers: positive infinity, negative infinity, does not exist. We're going to rule out does not exist because this is a one-sided limit. We are only finding one-sided limit, approaching -3 from the right. One-sided limit. Okay, so what we're going to do, we cannot factor x plus 3. So the only number that causes the denominator to be 0 is -3. Put -3 here. And we're trying to find the limit. X is approaching -3 from the right. -3 from the right in this direction. We're going to pick a number immediately to the left of to the right of -3. That will be a -2. That's your test value. -2 is bigger than -3. And that's the number we want to plug in the denominator. So the numerator is decided to be 2. Change x to -2. So -2 plus 3. That's a positive answer. So 12 over 1, that's so positive. So the answer is positive infinity is the answer to this question. I hope this was helpful, and thank you for watching.